Hello, hello. Yeah, so if you've got any questions, I mean, I'll say this now that you're here, but yeah, so if you or anybody else who turns up has any questions ahead of tomorrow's test, I will be happy to answer them. So again, that could be concepts from class, that could be specific questions from uh, examples in the lessons or from the homeworks. Um, And I'd be happy to go through anything like that for you. All I ask is that if it's an example out of a lesson, or really if it's an example out of the homework, uh, I'll have to pull up the questions. But since we're not in like school hours now, I can take the extra minute or two to look things up. So yeah, if you've got any questions, feel free. Otherwise, we can just hang out until somebody comes in with a question. Hello, hello. Oh, I see there's four people watching right now. I have no idea who all that might be, but awesome. Good to see the turnout. But yeah, so just like this morning's review session, I don't have anything specific that I prepared for this because um, basically the test questions are very similar to the kinds of stuff that you would have seen in the examples in the lessons and in the homework. So there shouldn't really be any surprises. You might find the odd question a little bit more challenging than the rest, like than the ones that we saw in class, but most of them should be fairly straightforward. So yeah, because I haven't prepared anything specific, I'm here to answer any questions that you guys have for the next hour ish. Like I'm not solid on it being like exactly an hour. If somebody comes in at 6:59 Dominican time and they say, I've got a serious question before tomorrow, I will stay longer to answer that. I'm having trouble with the multiplying decimals. Okay, right on. So let's talk about multiplying decimals. Um, Let me grab a marker and go through this concept again. So thank you for coming to this session because that's exactly what it's for. So with multiplying decimals, let's go through an example together. Um, Let me write something down on the whiteboard. So suppose we wanted to do something like this. Suppose we had a problem like this one, 27.3 times 2.4. So if this were a regular multiplication problem, let's pretend that this is a regular multiplication problem. So I'm going to write the decimals in a different color. I'm going to make them red, those two decimal points, and then we will ignore those while we go through the question. So here's the same problem, 27.3 times 2.4, and I've written the decimal points in red, and we're going to ignore those. So everything else is in blue. We're going to do this multiplication problem as if we only had the stuff in blue uh, in that question right there. So if we go through this like it's a regular multiplication problem, we start with this 4 here, and we're going to multiply it by each digit in the top. So we start with 4 times 3 is 12, carry the 1. 4 times 7 is 28, plus 1 is 29, carry the 2. 4 times 2 is 8, plus 2 is 10. And then I like to put an x there instead of a 0. And now we move on to this 2. 2 times 3 is 6. 2 times 7 is 14. Carry the 1. 2 times 2 is 4, plus 1 is 5. And then we have to add these numbers here. Um, Yes, after this, we can absolutely go over getting the common denominator for sure. Uh, so, so once we've gotten to this point, now we just need to add these up, right? So 2 plus, that's actually it's just like a 0. So 2 plus 0 is 2. 9 plus 6 is 15. Carry the 1. 4 plus 0 plus 1 is 5. And 5 plus 1 is 6. So now we're almost done. If this were a regular multiplication problem without those two decimal points in red, we'd be finished, right? Um, Now, the problem here, of course, is that we have those decimal points. So now what I'm going to do is this 3 and this 4, I'm going to change the color again. Give me one sec to do that because my markers are all over the place. But so let me rewrite that 3 in green, and I'll rewrite this 4 in green as well. Oh, green's not really cooperating with me today, but hopefully you guys can see that. There's 27.3 times 2.4. Same problem. All I've done is I've changed the color of these digits. Why these digits? I've changed the color of these digits because they're after the decimal point in each line. So the thing when it comes to multiplying decimals, the only tricky part is when you ignore the decimal points while you're working through the entire problem. Once you get to your answer, this 6552 down here, now we need to figure out where to place the decimal point. And so the idea here is that we're going to look at the two numbers that we multiplied together. So this 27.3 and the 2.4, we're going to look at these two numbers. And what we need to do is we need to ask ourselves, in total, between these two numbers, how many digits do we have after the decimal point? So basically, how many green digits do we have here? And so the answer to that is two, right? We've got this one here, and we've got this one here. So we've got one digit after the decimal point in the first number, and we've got one digit after the decimal point in the second number. So in total, that's two digits after the decimal point. All you have to do is make sure that in your final answer, you place the decimal point so that so let me say that again. So you've got two digits after the decimal point in these numbers that you're multiplying together. In your answer, you want to place the decimal point in such a way that you have the same number of digits after the decimal point. So up here, we've got two digits after the decimal point, this 3 and this 4. So down here, I'm going to put the decimal point right there so that we have these two digits after the decimal point. So we'll go through another example of this in just really quickly, and then we'll look at the common denominator thing because I just want to show you how this changes if we change the placement of the decimal point. So let me go through one more example like that, just so you can kind of see. So suppose we had something like, oh, I shouldn't write this all in red. I should write this in multiple colors. So where did my blue go? There's my blue. So suppose we have oh, actually, where's my eraser? I just realized I wasn't changing the number of digits we had after the decimal point, so I'm just fixing that. Um, so suppose we had something like 1.43 multiplied by 5.1. I'm going to show you the board in just a sec. So suppose we had something like 1.43 times 5.1, something like this, right? So hopefully you can tell the colors apart. So we've got the 1 is in blue and the 5 is in blue, and then that 4, 3, and 1 are all in green, and the decimal points are in red. So first things first, we're going to work through this like it's an actual regular old multiplication problem without the decimal points. So ignore the red decimal points. We'll just go through it like it's a regular multiplication problem. 1 times 3 is 3. 1 times 4 is 4. 1 times 1 is 1. And then in the second line, 5 times 3 is 15. Carry the 1. 5 times 4 is 20, plus 1 is 21. Carry the 2. 5 times 1 is 5, plus 2 is 7. And now we have to add these two together. So 3 plus 0 is 3. 4 plus 5 is 9. 1 plus 1 is 2. And then the 7 is by itself. And now we need to figure out where to place the decimal point. So if you'd like to, kind of race me to it and guess in the comments, or like, tell me what you think in the comment in the live chat. What you think the final answer should look like by putting in the decimal point. Should it be after the 7, after the 2, after the 9? Yeah, there you go. Yeah, so it should be 7.293. And the reason is, now you've got it right. So That 72.29. I think there's probably a typo somewhere there. Um, but so it is going to be right after the 7. And the reason for that is up here we've got these two digits are after the decimal point in the first one, and this 1 is after the decimal point in the second one. So in total, we've got these three digits after the decimal point. So in our final answer, we want to make sure we have three digits after the decimal point. So that's all there is to it. So you do it like it's a regular long multiplication problem. And then you just need to figure out how many digits you have after the decimal point up here, and then just match that number of digits after the decimal point down here. And that's all there is to it. So it's just like regular long multiplication. And then there's this one last step of figuring out where to place the dot. So I'm really happy you got that right. If you do have more questions or want to go through more examples of that, please do let me know. But for a moment, I'm going to jump over. We're going to look at the common denominator uh, business. So we'll do like an easy example and then a bit of a harder example. So you can kind of see how these problems change. So let's look at some common denominator stuff. So suppose we had something like, no, that we'll do that as the second example. Suppose we had something like, suppose we had something like this. We're doing an addition problem because it's only for addition and subtraction that you actually need a common denominator, right? For multiplication and division, that's not important. So in something like this, what we need to do is we need to get both of these fractions to have exactly the same denominator. Now, the way to do that usually is, so I'm going to tell you a couple of things. So the absolute easiest way to always make sure you get a common denominator is you multiply this denominator by that number and you multiply that denominator by this number. That will always get you a common denominator. It might be a bigger number than you needed it to be, and I'm going to show you that in this example. So for instance, I'm going to solve the question in red just so I don't mess with, so that we don't get confused between what the original question was and what I'm doing. So in this question, I'm going to solve this two ways. So the first way is look at these two numbers, this 6 right here and this 3 right here, and ask yourself if you can multiply just one of them by some number to get exactly the other one. So look at the smaller of these two numbers, this 3 right here, and ask yourself, is there something you can multiply 3 by to get an answer of 6? And in this case, the answer is yes. You could always, I'm going to just rewrite the whole thing, 1/6 plus 2/3. Now, this 3, if we take this 3 and we multiply it by 2, that's going to give us a 6, right? But whatever we do to the bottom, we also have to do to the top because otherwise we'd be changing the question. So if we multiply the denominator by 2, we also have to multiply the numerator by 2. So then this whole fraction here becomes, so we don't change the 1/6, but then this second fraction, we get 2 times 2 is 4, and 3 times 2 is 6. So you get something like that. And then now that you've got the common denominator, now you just add the two numerators together. So you get your 6 stays as the denominator, and then your numerator becomes 1 plus 4 is 5. So you get an answer of 5/6. Now, it's a little bit tricky. You have to be a little bit comfortable with kind of doing that guessing technique of like, oh, is there something I can multiply this one by to get to that one? It's usually pretty easy with the small numbers, but it's tricky once you get bigger denominators. If you've got a denominator like 12 or 24 or something, then it gets a little bit tricky to just look at it and know, oh, I can multiply something by a 3 or whatever um, to get that answer. So the other way you can get a common denominator, and this will always work, is you can multiply this denominator by that number, and you can multiply that denominator by this number. Now, the catch is you're going to end up with bigger numbers than you needed to. So you might have to do a little bit more work in the addition or subtraction, but you'll at least have a really, really easy way of getting the common denominator. So if we were to solve this a different way, which I'm going to do kind of over there, is we take this 6 and we multiply it by 3. And we're going to take that 3 and we're going to multiply it by 6. So you can already hopefully see that we're going to get exactly the same denominator, because this is 6 times 3 and this is the same thing, right? We've just written it in a different order, but it's still 6 times 3. Both of these are going to become 18, right? That's 6 times 3. So we know that we're going to get a denominator of 18 for both of these fractions, right? So we're going to get an 18 down here. We're going to get an 18 over there. Now we got to figure out what to do with these numerators. Now, in this first fraction, this 1 over 6, we multiplied the denominator by 3. So we have to also multiply the numerator by 3. So 1 times 3 is 3. So that's what was going to go over there. And in the second one, this 2/3 right here, we did 3 times 6 to get that 18 over there. So we're going to also have to do 2 times 6, which is 12. And so then you've got 3 over 18. That's nice. We got an 18 there, plus 12 over 18. So you've got a common denominator. And from this point, you can just add the numerators, just like we did down here. Is that once you've got a common denominator between the two terms, you can just add those numerators. So 3 plus 12, that's 15 over 18. Now, the catch here is if you compare these two solutions, this one had really small numbers the whole way through. We never saw any individual number that's bigger than 6, right? 6 was the biggest number we got. Up here, we got a 12, we got a 15, we got an 18, and we got to look at this answer of 15 over 18, and we got to ask ourselves, can this reduce down? Can we divide the numerator and the denominator by the same number to make this a smaller fraction that means the same thing? And the answer is we can, because if we divide the numerator by 3 and we divide the denominator by 3, 15 divided by 3 is going to be 5 over 18 divided by 3 is going to be 6. So we still get this answer of 5, 6. You see, it hasn't changed the answer at all. It's exactly the same answer that you get doing it both ways. This one has a little bit more to keep track of because you've got bigger numbers to work with, so it's a little bit harder. And then you also have to think about reducing. You're not always going to have to reduce. Sometimes the only way to get the common denominator is to multiply the two denominators together. And I'll show you an example of that as well in just a sec. But so here you can see there's two ways to do it. One, you kind of, if you're familiar enough with the numbers, you can kind of make a guess that like, oh, I only need to change one of the fractions and I can leave the other one untouched and get myself an answer with nice, neat, small numbers. The other way is multiply this denominator by that one, multiply that denominator by this one, do the same things to the numerators, and you'll eventually get the same answer. You'll just have some bigger numbers in between. So hopefully that makes sense. Now what I'm going to do is I'm going to erase this and we're going to do a slightly different question. I'm actually not going to change it very much at all. But I just want to show you that sometimes you don't have any other option than to uh, multiply the two denominators together. So suppose I change this question and instead of being 1/6 plus 2/3, suppose I make it something like this: 2/5, 2/5 plus 1/3, something like that. Okay. Now I'm going to show you another way that you can kind of check to see if you're on the right track with figuring out your common denominator. So if when you're dealing with really big numbers, sometimes you're going to have this problem of, if you've got really big denominators, if you've got like a 12 here and a 14 there, nobody wants to sit there and multiply 12 by 14 by hand in the middle of the test, right? So what you can do is, if you're not sure what your common denominator might be, what you can do is you can do something like this. So you write out a 5 and like put a circle around it so that you know that that's the 5 that you started with, and then just start writing out 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. So you just write these out: 5, 10, 15, 20, 25, as many as you think you need. And then do the same thing for this 3. So put the 3 with like a circle or something around it, and then put 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, and so on. And then see if you can find a number that shows up in both of those lines. And you'll always get at least one number that does show up in both of those lines. And so in this case, we see that this 15 shows up in the 5 line, but it also shows up in the 3 line, right? Now, if we look at these two lines here, when we were multiplying 5 times 1, 5 times 2, 5 times 3, it's the third number in that line, right? This is 5 times 3, right? 5 times 1, 5 times 2, 5 times 3 is 15. And then down here for the 3 line, this is 3 times 1, 3 times 2, 3 times 3, 3 times 4. This is 3 times 5. So this is how you can always check this. If you got really weird denominators of like 6 and 24 and you think that there's going to be a common denominator somewhere that's a little bit smaller than multiplying the two numbers together, uh, then you can write them out like this and look for numbers that are in common. Now, in this case, you'll notice, yes, you can say what you think is correct. Um, uh, in this case, you'll see that we've had a 5 as one denominator, we had a 3 as the other denominator, and in order to get a common denominator between them, which looks like it's going to be 15, we ended up actually just multiplying these two numbers by each other. 11 over 15. All right, let's check it out. Let's see if that's what we get. Um, what we got to do now is, so we know that 15 is going to be our common denominator because we wrote them out like this, and that's the first number that shows up in both lines. Now we just got to figure out, by using this and this, what to do to these fractions. So we know that 5 times 3 is going to give us 15, right? So whatever we do to the denominator, we also have to do to the numerator. And then, so I'll rewrite this down here. So we're going to have something plus something. Now for this one, this 3, to turn it into a 15, we had to multiply this by 5, right? 3 times 5. Whatever we do to the denominator, we also have to do to the numerator. So that's going to be 1 times 5 up there. And so now what we can do is we can write that out. So 2 times 3 is going to be 6. And then in the denominator, we've got 5 times 3 is 15. That's the whole reason we went through this, right? Is so that we could get this 15. And then over there, we've got 1 times 5 is 5. And 3 times 5 is 15. So there we go. So we've got a common denominator of 15. So we know that's going to be in our answer. And all we have to do now is add the two numerators. So we get 6 plus 5 is indeed 11 over 15. Nicely done. Yeah, it's 11 over 15, 11 fifteenths, whatever you want to say. Yeah, so that's the answer to this one. So you can see sometimes when you've got denominators like this, where one's not just a multiple of the other, right? It's not like turning a 3 into a 6. It's not like turning a 2 into a 4 or an 8 or something, right? It's weird numbers that don't really play nicely together, or don't play as nicely together in multiplication. Sometimes the only way to get a common denominator is to multiply them just by each other. The good thing with this method is that it'll work for any number. The other method doesn't always work, right? You can't multiply 3 by some nice, neat whole number to turn it into a 5. It's just not going to work, right? So you can only use that other method where you're only changing one of the fractions when you're absolutely sure that that's going to work, or you're really confident that that's going to work. If you're not sure about, oh, I don't know, if you're dealing with really big numbers, if you've got a 12 and a 48, right? And you're not really sure, can I just change the 12? Am I going to get to 48, or do I have to do something else? There's no denominators that big on the test, but if you're in that situation and you're not sure which method to use this one where you're just multiplying the two denominators together. Are you going to get bigger numbers than you needed? Yeah, sometimes, usually, but it's always going to work. So if you need to memorize just one way to do these types of questions, do this one, because this one works for absolutely everything. The other case is like a shortcut. The other one is like the easy way to do the question because you're good at spotting that 3 times 6 is 18 or whatever, right? Like you got to just be really good at your times tables to use the other one. This method will work for absolutely everything. So, yeah, so that's the questions that you guys had for multiplying decimals and common denominators. How are you feeling? Did that help? Yes, subtracting fractions is the same as adding, but with subtraction. So yeah, still find the common denominator. You can still use either of these methods that we just went over. All that changes is in this last step. Like we could actually, I could show you right now that if I just change that plus sign into a minus sign, right? Then I change this plus sign into a minus sign. And then in your final answer, instead of adding the two numerators, you do the subtraction problem. So 6 minus 5 would be 1. And that would be it. Yeah. So it's exactly the same thing as addition of fractions. You still find the common denominator and you can still find it using these same methods. The only thing that changes is in this step here, once you have your common denominator and you need to figure out the new numerator, is it's a subtraction problem instead of an addition one. So yeah, it did help. Oh, that's awesome. I'm glad. I'm glad it's helped. Yeah, so if you guys, if you're feeling more comfortable with that, then great. If you'd like to see another example, or if you saw something in the homework and it didn't make sense in one of the lessons, didn't make sense, let me know. I'd be happy to like redo one of those or come up with a new one. Um, but yeah, so also I'm confused on the place value with decimals. Okay, awesome. So let's talk about place values. So on the test, you're not going to see any questions about place values. It's just, it's a little helpful in general to be able to work with decimals. It's helpful to be comfortable with that kind of as an idea. The same way with fractions, I'm not going to quiz you on like, oh, label the numerator and the denominator, but it's just useful to have those words to be able to talk about it, right? Rather than saying like, oh, it's like the second number after the decimal point or something. They're just names. So let me write out some sort of a number. Um, so suppose we have something like, I don't know, I'll just pick something. Suppose we have like, I'll just keep it simple, right? We'll just write out a whole bunch of digits, kind of all in order, something like this. So the idea behind the place values is when you're looking at a whole number. So if this decimal wasn't there and we just had 1, 2, 3, that's hopefully easy peasy, right? This is the ones place, this is the tens place, and this is the hundreds place, and so on, right? Going further and further to the left, you'll get stuff like the thousands, the 10,000s, the 100,000s, and so on. Now, over on this side is where it's a whole new world of stuff, right? So, this first digit right after the decimal point, there's a nice big decimal point to look at. So, this first digit right after the decimal point, uh, how many of those do you need to create one whole number? So like the same way that you need 10 ones, 10 things that you put in this place to get to bump this number up by 1, you need to put 10 into that place, right? So if you think of these like the like what I was saying in the lesson of you of those little blocks, and then these things are rods, like in the tens place it's like little rods made up of 10 of those blocks, and then the hundreds place is those big squares that's made up of 10 of those rods. So you need 10 of these to make one of those, and then you need 10 of those to make one of those, right? um and then so on. Now, how many pieces here do you need to make one of these squares? Everything when we're writing out numbers is it goes by tens. So you need 10 of these to make one of those, you need 10 of those to make one of those, you need 10 of those to make the next one up the list, and it's always by tens. So if you've got a something in the ones place, just one of these individual pieces, and you want to break it up into chunks and put it after the decimal point, you're going to need 10 of them to make one of these, because going from every place to the next one, I didn't leave myself any room to draw anymore. um, but going from each of these lines to the one after it, you always need 10, right? You need 10 ones to make 10, and then you need 10 tens to make 100, and then you need 10 hundreds to make 1,000, and so on. So it's the same thing here. You need 10 of these things to make one, right? If you had one pizza and you wanted to cut it into 10 equal pieces, that's what each individual number that you go up by in this place would be one of those tenths. So the idea is basically if you had a number like if you had a number like 3.4, and you're talking about the number of pizzas you have. So this is saying you have three full pizzas, and then you've also got like a pizza that's been cut into 10 slices because everything's in tens, right? It's all every spot to the next one is all tens. So that's why the pizza's cut into 10 slices and you have four of them, right? So this is like you've got three full pizzas, and then you've got a part of a pizza, but you've only got four out of the 10 slices, right? Now, if you had all of those slices, you'd have a whole nother pizza, right? But because you need 10 slices in total to make a whole, we call these tenths. So the same way that you have like um if you've got like a fraction like 1 over 3, this thing is you're going to be talking in thirds, right? One third, two thirds. If you had 1 over 4, this is 1/4, 2/4, 3/4. If you had 1/5, this is going to be, well, if you had 1 over 5, that's going to be 1/5, 2/5, 3/5, 4/5, right? And so basically, when you're dealing with this first digit after the decimal point, that's basically saying it's like you're working with a fraction where you've got a 10 as the denominator. So this is 1/10, 2/10, 3/10, 4/10, and so on. And then you just kind of go almost in backwards order. Like on this side, we're going ones, tens, hundreds, thousands, 10,000s, and you go further and further left. On this side, we've got tenths, and then here we've got hundredths, and then here we've got thousandths, and then here we've got 10,000ths. So basically, it's it's telling you um, it's telling you that how many pieces like this far down the line past the decimal point, how many of those tiny tiny pieces you'd have to put together to make one whole thing. So if you had 3.4, this point 4 is telling you that you've only broken the whole up into 10 pieces and you need 10 of them to make one, so we call them tenths. If you had a number that was like 3.14, now all of a sudden you need to get 100 pieces to make a whole one and bump this 3 up into a 4. So because you need 100 of them in total, we call this last number here the hundredths place. So I know it's a little bit confusing with the place values. It's just a useful terminology to be able to talk about them so that you don't have to say the third digit after the decimal point, or like, oh no, not that one, there's a zero there. And just to have like a vocabulary to be able to talk about where these digits are. Um, that's all that it's there for. So I hope that clears it up a little bit. I know it's a little bit of a confusing topic because you have to stick the th on the end and you go in the backwards order from what you're used to seeing. Suddenly a tenth is bigger than a hundredth, even though 100 is bigger than 10. Like, I know it's a big confusing mess sometimes, and I'm sorry, but that's the way that math is sometimes. I'm going to try to make sure that you guys leave this class thinking that, like, okay, you know what, math is actually pretty reasonable. This is one of those things that it just takes a little bit of time to get used to it, but I hope that helps a little bit. Hey, Mr. Barry, could you please go over add, subtract, multiply, divide fractions with a whole number next to it? Yes, absolutely. Okay, great question. Adding, subtracting, multiplying, and dividing fractions with a whole number next to it. So you mean like a mixed number where you've got like a whole and then a little piece left over? Let me write out an example and then stop me if I'm doing something wrong. Uh, so suppose we had something like Suppose we had something like this: 3 1/4 plus 2 and a fifth, something like that, right? So there's a couple things I could say here. The first thing is when it comes to addition and subtraction, only, not multiplication and division. Multiplication and division, it's a whole lot easier if you do it a different way. Okay, this is it. Okay, awesome. So for addition and subtraction, this is similar to what I was saying earlier on, that there's sort of a shortcut if you're comfortable. So the shortcut is you can add the two whole numbers separately. So like you see this 3 and that 2, we say, well, 3 plus 2, it's going to be 5, and then there's going to be something left over. There's going to be a little fraction left over that comes from this 1 over 4 and this 1 over 5 are going to come together to make something. So basically what I'm doing with this question here is I'm breaking it up into 3, a quarter, 2, a fifth, and I'm just adding all of those together. And I'm saying, let me deal with the whole numbers first and call that 5. And then you've got this addition problem left over with the mini proper fractions next to it. And you can go through that whole process of getting a common denominator. So in this case, for instance, if we take that, if I make that a little bit bigger, so we've got 1/4 plus 1/5. Suppose you multiply this 4 by 5 and do 5 times 4. Then you do the same thing to the numerators. And so you'll get 5 over 20 plus 4 over 20. So you'll get 9 over 20. So that would be your leftover fraction right here. So it would be 5 and 9/20 would be your final answer to a question like this. Now, the thing with addition and subtraction, yes, you can do it this way. Subtraction with mixed numbers is a little bit of a nightmare if you ever have to do like borrowing. Like if you have, like if the leftover piece in the second number is bigger than the leftover piece in the first number, it's a little bit of a nightmare with mixed fractions. I'm not going to lie. I was always comfortable with math in school. I don't like doing subtraction of mixed numbers because it's a nightmare. So, what I would recommend instead, and the thing that'll work for addition and subtraction and multiplication and division, is turn everything into an improper fraction. So let me, oh, I erased the question, but let me just rewrite that. So if you had 3 and a quarter, and then you had 2 and a fifth. So these are your two numbers. Let's keep it as an addition problem for the time being. All if you want one like surefire, one size fits all kind of an answer, turn everything into an improper fraction and then change what you need. So for instance, if with this first one, to turn this into an improper fraction, we take this denominator, we multiply it by that whole number, and then we add the numerator. So 4 times 3 is 12, plus 1 is 13 over 4. And then over there we get 5 times 2 is 10, plus 1 is 11 over 5. And now we've got this addition problem. And then you do the exact same thing to try and find the common denominator. Yes, you're working with bigger numbers. I know. We've got the 13 here, we got the 11 there. We didn't have those big numbers last time. I know. That's the unfortunate trade-off that we're making here. But so you take this 4, multiply it by 5, 5, multiply it by 4, do the same things to the numerators. And then this will take a little bit of work sometimes because you're dealing with kind of numbers of a scary size, right? So we've got bigger numbers in our numerators, not really in our denominators. So we got 5 times 4 is 20, 5 times 4 is 20. So our denominators are all set. And we're going to have something over 20 when we're done. This one's easy. 11 times 4 is 44 because it's just multiplying by 11 isn't that hard when it's by small numbers. This 13 times 5 is probably the scariest part of this problem. So if you need to sit down and do like a mini long multiplication problem in the middle of your question, that's okay. Sometimes you got to do that. So 5 times 3 is 15. Carry the 1. 5 times 1 is 5, plus 1 is 6. So you get 65. So we get 65 right here. And then we have the 44 over there. And then now, because we've got the common denominator, we just add the two numerators. So 65 plus 44, that's what, 109? So you'd get 109 over 20. And then now it would be best as a final step to turn this back into a mixed number. So you ask yourself, how many times does 20 go into 109? Well, 20 times 5 is going to be 100, right? 20 times 5 is 100. So we know we can make 5 wholes out of this, but we needed 109, not 100, right? So we have 9 leftover bits. So that's where you get that leftover piece on the end. And that's the same answer that we got using the other method, was 5 and then 9 over 20 as the proper fraction left over. Now the good thing about this method, I know it kind of sucks to have the big numbers and get like the 65 and the 44. I know we weren't having those problems when it was 1/4 and 1/5 and small numbers, small fractions. I know it was nicer that way. But this way, if I turn this into a subtraction problem, you can still do all this, right? All the plus signs become minus signs, but you can still do this. If I turn this into a multiplication problem, sure, this becomes a multiplication sign, but you can still do that. In multiplication, you just multiply the two numerators, you multiply the two denominators, a little bit of reducing if you can, and you're done. If I turn this into a division sign, no problem. I turn this into a division sign, you flip the second fraction, you turn the division sign into multiplication, and we're laughing, right? So that's the brilliance of this method of turning your mixed numbers into improper fractions. Is this could be an addition problem, a subtraction problem, a multiplication problem, or a division problem. As soon as you turn 3 and 1/4 into 13/4, and you turn 2 and 1/5 into 11/5, you don't care what the sign is in between because they're all easy now. They're all so much easier to work with. Multiplication with mixed numbers, I don't want to do that. Multiplication like this, we're so happy because you just multiply and by going across. If it's division, first you flip the second fraction over and then you multiply going across. So my advice would be, if you're stuck with the mixed numbers, turn them into improper fractions, because yes, it's an extra step at the beginning and maybe at the end, but okay, so I think the first method is better for adding and subtracting, and the second one for multiplication and division. Yeah, so by and large, I would say that's true. Mostly, you can use the first one for addition and subtraction. Let me show you briefly why I don't really like it for subtraction. You can do it. You can do it. Let me show you why borrowing for fractions is a nightmare for subtraction sometimes. So suppose I gave you a question that was like, let me say something like this. Let me say, uh, let me make that even bigger, actually. So let me say 5 and 1/6 minus 2 and 3/4. Right? So if you try to do the first method for this, you're going to deal with the whole numbers first, right? You're going to say, okay, well, 5 minus 2, that's 3. And then I'm going to have something left over, and I got to figure that out with the remaining pieces. Here's the problem with the remaining pieces. Your remaining pieces are 1/6 minus 3/4. And if you go through the trouble of getting a common denominator there, you're going to get 2/12 minus 9/12, which is -7/12. But we can't write a teeny weeny little negative here. That's not right. You can't write a mixed number with a negative in the fraction. So this whole thing breaks. And what you end up having to do is you have to borrow from this 2. The same way that, like, if you're doing a subtraction question and you've got something like, I don't know, like 21 minus 9, for say, for instance, right? And you have to do this borrowing where you turn this 2 into a 1 and then you add a 10 there, so you get 11 minus 9 is 2. It's like that, but now you're doing it with fractions. And so the thing that's not fun about that is when you're looking at this 2 and 1/4, you have to borrow from this 2, but instead of adding 10, you've got to add whatever the denominator is to the numerator. So you turn this 2. So basically what you're doing is you've got what this fraction right here is telling you is you've got 2 full pizzas and then you've got 3/4 of a pizza. Yeah, that's what this one right here is telling you. This 2 and 3/4. That's what this looks like. Now, in order to do this borrowing, basically what I'm saying is you got to get rid of one of the whole pizzas and cut it into pieces. So you take one of these whole pizzas and you cut it into 4 slices. So now this 2 and 3/4 becomes one whole pizza, right? And then we've also got one, two, three, 4 pieces of this pizza and 3 pieces of that one. And so what you end up with is you've got a very really funny looking fraction. You've got 1 and 7/4 pizzas, right? That's what this diagram is right here. You got one whole pizza and then 7 extra slices that are all a quarter of the pizza. This is exactly the same fraction as that guy up there. 2 and 3/4 is the same thing as 1 and 7/4. But that's the kind of borrowing that you have to do this subtraction problem. Um, but yeah, you see what I'm saying? That it's just it ends up being hard. And actually, I think I actually am so I've actually borrowed from the wrong place. I should have actually done the borrowing over here. I should have been cutting this 5 into a 4 and then adding stuff over there. But it's you see how it's hard, right? So yeah, don't do it that way for subtraction. Basically, you can do that first method for addition, no problem, and you can do it for subtraction if the two little leftover pieces aren't going to give you a negative answer. So if the first fraction is bigger than the second fraction, then no problem. Yeah, right? Yeah, I hope I don't see that on the test. You're not gonna see it on the test. If I throw it on the exam, in a few months, I will let you guys know, and I will go through an example before I make you do that. Chances are you're not gonna see it because it's a nightmare, right? You guys just saw that. It's not fun. That looks almost impossible. Yeah, it's not fun, right? And, like, even I just in trying to explain it, I borrowed from the wrong fraction. I was supposed to borrow from the other one. I borrowed it from the second one instead of the first. I don't like it. I went to university for 4 years, actually for 6 years for physics, and I can't do subtraction of mixed numbers. Like, I don't do it. Convert everything into an improper fraction if you can, except for addition. Because for addition, it's easy. Addition is everybody's best friend, right? You take the 2 whole numbers, put them together, take the 2 fractions, put them together. If you add the 2 fractions together and you get a new mixed number, like it's all like you get 1 and a little bit, then just tack on that extra 1, add it to the the whole number that you already got from before, no problem. But yeah, I would say that for subtraction, multiplication, and division, turn everything into an improper fraction because it's easier to work with the numbers. It's easier to find the common denominator because you don't have these giant whole numbers floating around next to the fractions. It just looks so much cleaner, right? When it's you've just got a fraction here, a fraction here. If they're proper fractions or improper fractions, as long as it's not a mixed number, you don't care what the sign is in between because you know how to find the common denominator, you know how to add, you know how to subtract, you know how to multiply, you know how to divide. And that's all you need, right? You need to know how to find the common denominator, and then you need to know how to do addition, subtraction, multiplication, division, and that's it, and you're done. So my advice would be change everything to a common denominator, except maybe uh, for addition, or change everything to an improper fraction, except maybe for addition. For addition, maybe you can add the mixed numbers together. Um, yeah, my personal advice: change everything to improper fractions, and then if it's addition or subtraction, get yourself a common denominator and go from there. Yes, sometimes you get the bigger numbers. Sometimes you get 65 over 13 and it's not fun, right? But you know that that happens sometimes. So yeah, I hope that helps with the just dealing with the mixed numbers. It's a bit of a nightmare. But I believe that I haven't done that to you on the test. I don't think I've asked you to add, subtract, multiply, or divide anything with mixed numbers. I asked you to do a little bit of conversion. Can you give us some practice questions? For sure. Um, any specific topics? Just the ones that we've covered today, or something else? Do the second method every time. The ones that we covered. Absolutely. Yeah, let me give you some practice questions. Let me also remind myself what all we've covered because my brain is not working. Multiplying decimals. Yeah, we'll start there. Yeah, so let me give you like two examples of multiplying decimals, two examples of like finding common denominators. Um, and and then we'll see after that, maybe we'll do some as well for like addition, subtraction, multiplication, division with mixed numbers. So let me give you a couple that you can work on for a few minutes. So here's some multiplication with decimals. Let me give you these two to start. So start with these. Take a second, write these down, take a picture, whatever it is you need. And then I'll hold the board up again in just a sec. But I'm gonna come up with a couple of questions for finding the common denominator, and then we'll see how we're doing after that. If you guys want examples with the mixed numbers, we can do that too. I absolutely do not mind. So yeah, write those down. Take a picture so that you can write them down in a sec, and I will come up with a couple of examples for finding the common denominator. Let's say. Okay, so what I'm going to do is I will hold up the board, but first I'm going to take a picture of these questions so that if you want me to work through the answers, I can erase the questions and then retrieve them from my phone. So here are your questions. Take a few minutes to work through these and then leave something in the chat when you are ready to check the answers. I've come up with these on the spot, so I haven't worked through them. I know the answers without sitting for a second. But we can go through the answers to these questions together. You'll see with the last one, I've kind of combined things a little bit. I've made it a mix of mixed numbers and oh, sweet. You're done with the multiplications. Awesome. But yeah, this last one, I've made it a combination of dealing with the mixed numbers and also the common denominator. So this last question probably involves the most stuff that we've done today. But sweet. Yeah, I'll give you guys a couple of minutes to work on those. And then we will we'll start from the top and we'll just work our way down. I'll wait like 30 seconds so that you guys can write down the questions and then I'll start working through them so that you can, and I'll start working through them from the top down. So, so you can kind of follow along. But all right, so let me grab my marker and I will erase the bottom three questions just so I have a little bit of space to work with. So let's go through this multiplication. So we'll start with this 7.21 multiplied by 0.9. Cool. So the nice thing with when you're multiplying by something like 0.9, like 0 point and then just one digit, is you don't have any extra work to do with this zero, right? It's just three digits times one digit, right? So we've got 9 times 1 is 9. 9 times 2 is 18. Carry the 1. 9 times 7 is 63, plus 1 is 64. And that's it, because we don't have to do anything with the 0, but we do need to figure out where to place the decimal points. So, do you want to give your answer for the first multiplication one? Where do you guys think the decimal point goes? After the 6, the 4, the 8, the 9, before the 6? All done. Sweet. Okay, so we'll go through these. What's your answer for the first one? 6.389. 6.489. Yes, after the 6. Yeah, 6.489, just because we got to carry that 1 there. Right on. So the decimal point goes here because we got 1, 2, 3 digits after the decimal point. 1, 2, 3 digits after the decimal point. Yeah, awesome. 6.489. Fantastic. So that's it for the first one. The second question was, I forget, so I'm going to check my phone. 3.844. Is that the second one? 3.1 times 1.24. Okay, yeah. So, pro tip for the test with the second question. So I wrote it this way on purpose. 3.1 times 1.24. Yeah, this is what I wrote. Now, naturally, uh, when you see a multiplication problem like this, a lot of people would like to say, okay, well, 3.1 times 1.24. But if you write the bigger number on the bottom, you're going to have more lines of work, right? You're going to have to do this whole multiplication going across more times. You got to keep track of moving things over one place to the left. I don't do it that way. I'll always put, for multiplication, because the order doesn't matter, I'll always put the bigger number on the top. So I'll do 1.24 times 3.1. And so then we can do this. 1 times 4 is 4. 1 times 2 is 2. 1 times 1 is 1. 3 times 4 is 12. Carry the 1. 3 times 2 is 6. Plus 1 is 7. 3 times 1 is 3. And then we have to add. 4 plus 0 is 4. 2 plus 2 is 4. 7 plus 1 is 8. And the 3 is by itself. And you put the decimal point after the 3. Excellent. So, if everybody else who's also working through the questions got this as your answer, that is right, because we've got 1, 2, 3 digits after the decimal point up there, and we've got 1, 2, 3 digits after the decimal point down here. Sweet. So that's 3.844. That's the second question. And it doesn't change if you flip the order. If you wrote 3.1 on the top and 1.24 at the bottom, it doesn't change anything. You should get the same answer, and the rule for like counting up the decimal places, none of that changes. So you can do it whichever way you want. I just did it the way that I find a little bit easier, and that's all. Next up is 5/6. 5/6 minus a quarter. So now we're finding common denominators and such, right? Nice pro tip. Never thought of that. Yeah, always look for those little ways that make things easier for you. So, just before I jump into the next question, if I give you a multiplication question, like if I gave you something like this, in my mind, I just like to have the small digits, the ones, the twos, the threes, as the second number, because that's the one that you're constantly multiplying by things and carrying things. You're never going to have a huge number that you're carrying if you got ones, twos, and threes down here. You can totally do this question by doing 1.212 times 7.989. But then you're going to be doing 9 times things and 8 times things. And it feels harder to me to do it that way. Like in my mind, when I was in like whatever grade 3 or 4 learning original, like not with the decimal points, but when I was learning like original long multiplication, I just like having the smaller numbers on the bottom. So find what works for you. Make sure that you're not changing the question. But other than that, absolutely. Come up with the pro tips, find what works for you, make things easier. Because it'll save you time, it'll save you stress, it'll save you all of that. So, okay, let's go to the next question. That's 5/6 minus 1/4. Okay, so what we need to do here is we need to find a common denominator. Now, if you guys can type quickly, just shout out what was your denominator, not your whole answer. What was your denominator in your answer? Because there's a couple ways you could do this. Yeah, sure, you can give me the answer. I don't mind. Yeah. Okay, so your denominator was 12. Okay, good. So you could get it with okay, awesome. So you got 7 over 12. Okay, good. So there's two ways you can do this. One way is you write out the two denominators. So we've got our 6 line and our 4 line. So in our 6 line, we do 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and so on. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and so on. And then we see that we've got a 12 here and a 12 there, right? And so then we know, okay, well, I can get 6 to 12 is that's just 6 times 2, and 4 to get it to 12, that's 4 times 3. So now you know everything that you need to do here. So we've got 4 times 3, 1 times 3, 6 times 2, and 5 times 2. So then you get that's 10 over 12 minus 3 over 12, which is indeed 7 over 12. Very nice. Awesome. Yeah. Now the other way that you could have done this is if you're not sure with like this method and like writing all this stuff out, is you look at these two denominators and you're not sure exactly what the common denominator will be. You can always just multiply the two denominators by each other. That will work 100% of the time. So this could be 6 times 4 and 4 times 6, and then 5 times 4 and 1 times 6. So then you'd end up with 20 over 24 minus 6 over 24, which is 14 over 24. And then you just have to do a little bit of reducing here, noticing that both of those are even numbers. So you could divide by 2, and then you get 14 divided by 2 is 7, 24 divided by 2 is 12. And you see that that gives you the same answer. So both of those methods absolutely will work. Um, Pick whichever one works better for you. I don't have a preference personally between these two. I maybe have a slight preference to the first way that we solved it because the numbers stay a little bit smaller. Um, but yeah, so I'm glad you guys got the answer. And the thing is, if you just tell me that answer, right? So, a couple things I want to say before we do the last question. If you just tell me the answer, looking at this, and it's like, oh, you got 7 over 12. If you just tell me 7 over 12, I have no idea which method you used, right? Because even this second method down here requires that reducing step at the end. The answers look the same, right? When you're finished. Now, the related thing that I just wanted to say quickly before we do the last question is the importance of showing your work. Now, the reason I emphasize showing your work is suppose you did all of this work to get to the 12, right? You wrote out this line kind of in your head. You didn't write it down on paper, but in your head, you figured out, okay, well, 6 times 2 is 12 and 4 times 3 is 12. But then over here, you write down, suppose you don't write any of this stuff down on the page and you don't write any of this down on the page, but somewhere you make a little mistake. Either you forget that this is a 3 and you write down a 4 or a 6 because it was multiplying by you're just there's a lot of numbers going on in your head. So maybe you write down a different number and instead of getting a 7 you get a 6. Maybe you forgot that it's a subtraction question, you write it as an addition question, you get a 13 instead. If you write only the answer, if I gave you this 5 over 6 minus a quarter, and you tell me the answer is 13 over 12 without any other information, I can't give you any marks because the answer is wrong and you didn't show me your steps. But if you showed me this, if you showed me that you wrote down all of that stuff to get the 12, and you showed me this, that you did this work, but you just put a plus sign here by mistake, I'm going to basically give you the marks, right? If it's a 2 mark question, I'm giving you 1.5 out of 2 if you showed me all that work. Because then I can see, okay, you've got the process down. It's a typo. You wrote a plus sign instead of a minus sign and you got the wrong answer. So it's minus half a mark out of 2, but that's it. But if you give me just this and it's wrong, I can't do anything with that because I don't know where you went wrong. I don't know if you guessed. I don't know if you did everything right except for a typo. I don't know if you were way out of left field and you were trying to add without common denominators and then you somehow got a 12 at the bottom. I don't know, right? So that's why I say show your work. Yes, it's absolutely a math teacher phrase because that's what it that's the importance that it has for me is that I can't give you the marks if you get the question wrong and you don't show me your work. So because you don't know necessarily if you got the question right, if you've got it wrong, I need to see the steps that you took to get there because then I can still give you most of the marks. One of my questions in a physics exam in university, I did like completely wrong. Like from step one, screwed up the entire question from the get go. I got 3.5 marks out of 4 because despite making a mistake in line number one, the entire rest of my process made sense. So my buddy next to me didn't show his work, got 1 out of 4, even though he did more of the question right, but because he didn't show it. So that's why I say what I say. Um, let's do the last question, just in case you guys have to go. I'm actually more than happy to stay if you guys want to do like more practice questions or something. But I don't know if you guys have to go, so that's all. All right, let's go through this one. So this is 1 and 2/3 plus 2 and 1/5. So following the advice that I gave you guys, I'm going to turn everything into an improper fraction, uh, just because it's easier. Even though it's an addition problem and maybe I could get away with the other method, I'm going to turn everything into 3 wholes, and then 13 over 15 is the answer for that one. All right, let's check it out. So I'm happy already with just a couple of things. I'm happy that I'm looking at this question without doing any of the work. I know it's 1 plus 2 is 3, and I'm going to have something left over. So I'm already happy to see 3 holes. I see a 3 in the denominator here. I see a 5 in the denominator there. I'm already happy to see the 15 in the denominator. Let's work through it. So I'm going to turn these into improper fractions. That's 3 times 1 is 3 plus 2 is 5. So that's 5 over 3 plus, and then 5 times 2 is 10 plus 1 is 11 over 5. This is a horrible 3 over here. So 5 over 3 plus 11 over 5. Now to get a common denominator, I'm going to multiply this by 5. I'm going to multiply that by 3, and I'm going to do the same thing to the numerators. So we get 25 over 15 plus 33 over 15. So yeah, a little bit of a downside because we got these huge numbers. 33 plus 25, that's going to be 58 over 15. And then now I know basically from being a football fan, you get good at dealing with 15s and 30s and 45s, but your times table for 15, you got 15 times 1 is 15, times 2 is 30, times 3 is 45, times 4 is 60. So we know we can make 3 holes, which will account for 45 out of the 58 pieces, but then we have 13 left over. So it is going to be 3 and 13 over 15, right? Yeah, it is true. Yeah, you get really good at like dealing with 45s and 15s and 30s and stuff by following a sport that likes to use those numbers. But yes, very well done. Yeah, that is 3 and 13 over 15. Right on. So you guys have nailed the practice questions. If you had any trouble with those, if you've got other questions that you'd like me to address, if you want test tips, I'm still here. I got time. I got time if you guys want to go through uh, anything extra. Um, but yeah, that's there's nothing too complicated on the test. One of the word problems is like barely any work. One of the word problems is considerably more work, but nothing is out and out hard on the test. So um, hopefully that covers kind of everything that you guys wanted to know. Am more than happy to stick around if you guys have more questions, but if it's just silence in the chat, I'll hang out for like 5 minutes and then I'll call it. But always available: WhatsApp, Instagram, YouTube comments. Um, Good. My team's doing well. They won 7-1 on Saturday, so I'm very happy about that. Um, yeah, I know they had some rough results the last time I was there with you guys, but they won 7-1 on the weekend, so that's awesome. I'm gonna go practice all of it now. Awesome. Um, Yeah, right on. I am available if you guys have questions, particularly on Instagram and WhatsApp, just because those are on my phone. YouTube is also on my phone, but it's on my like personal YouTube, so I don't get notifications of like comments being left on my videos. But honestly, if you have questions, uh, you know, find me on Instagram or like get your parents to look me up on Instagram because the handle is in all of our lessons. Um, or get them to send me a WhatsApp message if you guys have access to my WhatsApp. But I'll check my YouTube comments in like 2 or 3 hours before. I shouldn't leave it for 3 hours, but I'll check in like hour and a half, 2 hours in case you guys have posted any last minute questions there. But yeah, I'm on my phone. If you guys have trouble, let me know. Thanks for all the help. I really needed it. No problem. That's what I'm here for. Um, yeah, it's a little bit of a challenge for me because I don't get to see your guys' faces when I'm teaching in class, right? Like I make the videos the night before, I record them in front of a camera and I post them. I don't get to see what's confusing, what's not confusing. Most of you I haven't met in person. Obviously, there's a couple of you that, I remember from years back, but most of you I haven't seen before. You guys haven't seen me before. As far as you're concerned, I'm some random guy on the internet, right? But I want to make math something that you're not scared of because I know math is something that's scary to a lot of people. Um, but I want to show you guys that it's it's fun and it's not always the hardest thing and it can be useful. So yeah, I'm more than happy to to carve some time out for you guys. If you've ever got questions, always reach out. I'm on YouTube all the time. I'll be more regular with checking the comments and stuff. Instagram and WhatsApp 24/7. You can call me in the middle of the night panicking about the math test and assuming I wake up from the ringing of my phone, I will help you out. Like I don't want you guys to be scared. I'm not out to like throw you curveballs on the tests or anything like that. Good luck with the practice, but let me know if you need help. Yeah. Other than that, I'm hanging out for a little bit. I will make a note in my phone to check YouTube comments in a couple hours because I'm going to be playing chess with a buddy of mine in hour and a half or so. So there's a chance that I forget if I don't make a note, but I will do that now. Check YT comments. So I'll set that for like tonight at 8 p.m. my time, which I guess is 9 o'clock your time. So if you're in like big trouble last minute, I will help you out by 9 p.m., 9:05, something like that. Um, but yeah, any questions? If I don't know, I keep seeing the attendance count in the live chat like flicker between 2 and 4, but I don't know if it's the same 2 to 4 people or if it's different people. So if anybody's here that's like a straggler from that like wasn't here at the beginning and you have questions, I'm happy to stick around. I got another hour free. I'm happy to hang out. But yeah, no, if that answers all your questions, don't stay. Go either finish your studying or enjoy yourselves because you're only young once. So enjoy, have some fun. Um, I'm here if you need me, but I hope that answers everything. Oh, we got 5 people here. Once again, I don't know who's been here the whole time and who hasn't, but if you guys got questions, I'm still here until the chat goes silent for like 5 minutes. So like, what is it? It's like 6:15 my time, 7:15 your guys' time. So yeah, if it's still quiet at 6:20, 7:20, and nobody's got any questions, then I will end the stream. But I got time if you guys got questions. One last thing I'm not sure about. It's dividing two numbers with decimals. For example, 19.6 divided by 1.4. Okay, yes. So, I hope I didn't give anything like this on the test because it is probably the hardest thing with dividing decimals. So here's the the tip for ones like that, because I would never make the question more complicated than having just like one digit after the decimal point in your divisor in your second number there. So here's my tip for dealing with that. So suppose we've got a question like what is it? Oh, it's 19.6 divided by 1.4. I think this is one of the ones I put in the practice. And I think I briefly mentioned how I would go about it. So here's the thing. Let me write this out like a fraction. I know it's weird to put decimals in fractions, but so we've got something like 19.6 over 1.4. Yeah. Now I'm going to explain why I've written it out like a fraction. So we know that if you've got a fraction, let's just take like a normal looking fraction, something like 2/3, and we need to find a common denominator. We got to change things around a little bit. Then we know that if we multiply the denominator by something, right, we're trying to get to a certain number, then we have to do the same thing to the top number. Now, why is that? The reason we do that is because we've got something like whatever, 2/3. And what we're really doing is 2/3 times something like 6/6. But 6/6 is just equal to 1. And so is 4/4 and 5/5 and 22/22, right? As long as the numerator and denominator here are the same as each other, you're not changing the question. You're multiplying by 1, which never changes the question, right? So over here, if I look at this fraction, I want to multiply by the same number top and bottom so that I'm multiplying by 1 to make life a little bit easier. Now, what would be an easier number to work with than 1.4? For me, I really, really wish the decimal point wasn't there. That's all, right? Of all the things I could want in the world, all I want is that that decimal point is not there. How do I turn 1.4 into 14? Just to get rid of the decimal point. To do that, I have to multiply by 10, right? So what I'll do is I'll multiply by 10 over 10 because I want to multiply by 10 in the denominator so that I can get rid of the decimal point basically. But whatever I do to the denominator, I also have to do to the numerator. So I also have to multiply the top by 10. So what actually ends up happening in this example is both the decimal points just evaporate. So they just disappear. So instead of 19.6, you end up with 196 over 14. Now it's a regular division question. So it looks like decimal long division. It's not. It's regular division. And I would never give you anything harder than one digit after the decimal. If I gave you a second one, if I gave you a second digit there, that's fine. Multiply by 100 instead, so that that gets chucked all the way over there. All you care about is turning this number, this divisor, the second number, into a whole number, because then the division gets a whole lot easier. Obviously, the longer it gets, the bigger your number gets once you multiply by a bunch of stuff. Nobody wants to divide by 142 in their head, but that's it. Multiply and divide by 10 so that you can get rid of the decimal point in the divisor. If the decimal point in the dividend also evaporates, great. If you didn't have a decimal point and then you multiply by 10, that's fine. You end up with a 0 on the end of it. I'm sorry I left and I came back. How do you do that? Yeah. Let me re-explain this from the start. Um, so you've got something like 19.6 divided by 1.4. You got 19.6 divided by 1.4, right? So what I said is let's write this out as a fraction. 19.6 over 1.4. I know it looks weird to have the decimals in the fractions, but because I'm re-explaining it, I'm going top to bottom. So if we've got this fraction, the reason I've put it as a fraction is let's look at a regular fraction like 2/3, right? If you had to get a common denominator with this 3 down here and you had to turn it into something else, you had to turn it into a 16 or an 18 or something, right? If you had to turn it into an 18, you multiply the bottom by 6, you multiply the top by the same thing. Now, why do we do that? That's because you've got 2/3. What you're basically doing is you're multiplying by 6/6, right? Because multiplication with fractions, you just go across, right? 2 times 6, that's this 2 times 6 right here. 3 times 6, that's just this 3 times 6 right here. So this is basically what we're doing, but this thing is just 1. As long as the numerator and denominator are the same, it's just 1, right? That could be 6 over 6, it could be 4 over 4, it could be 32 over 32. It's 1. What you're multiplying by here is 1. So, following that same logic, what I want to do is I want to multiply this denominator, this 1.4 here. I want to multiply this by something that gets rid of that decimal point. Now, how do you turn 1.4 into something like 14, where you just get rid of the decimal point entirely? You can do that by multiplying by 10. Always your easiest option. There's smaller whole numbers you can get with 1.4. Like if you multiply it by 5, you'll get 7, but that's harder to spot. So the default is if you've got one digit after the decimal point, just multiply it by 10, you get rid of the decimal point entirely. So what I want to do is I want to multiply this denominator by 10 so that I get rid of the decimal in my divisor. But whatever I do to the bottom, I have to do to the top. So I multiply and divide by 10, top and bottom. So then at the bottom, we've got 1.4 times 10 is 14. That's cool. We got rid of the decimal point. That was the whole purpose. And then on the top, we've got 19.6 times 10 becomes 196. So it actually stops being a decimal long division question. It's actually just a regular long division question. But even if there was a decimal on top, or if there was no decimal on top, not a problem. If the decimal was over here instead of there, no problem. Then instead of 1.96, it would become 19.6. No biggie. All that we cared about was getting rid of the decimal from our denominator. If you had no decimal up here before, that's fine. Then you're multiplying by 10. That's easy. You just add a 0. What we cared about with this multiplication right here is getting rid of that decimal point right in there. So that's the hardest thing with long division, is that if you've got digits after the decimal point in this second number in the divisor, then the way I like to solve that is I like to multiply top and bottom by 10. The dividend and the divisor, I like to multiply both of them by 10, or if I need to do by 100 or 1,000 or whatever, I'd like to do that because I want to get rid of the decimal in my divisor. There are other ways to do it, but I'll never give a question that's harder than having one digit after the decimal point in your divisor. I don't think there's anything like that on the test. I'm not certain, so study it just in case, but don't spend too long on it because I don't think I did that to you guys. Um, I may have done it once by mistake, but I definitely did not mean to. So, yeah, hopefully it's easier than it looks. You will hopefully find that it's not too complicated once you think about it. But it's also not the easiest thing to come up with. As you guys, do more math, if you ever, yeah, no problem. If you ever, like go to university to study math or do math courses or anything like that, you'll see that a lot of times in math, there's stuff that mathematicians do that you don't really think of, but they're like, "Oh, I recognize this. It looks like an easier the question I have to do looks like a harder version of a problem that I already know how to do." So they'll turn it into the easier version and then solve that because they know how to do that. So that's basically what's going on here. You know how to do long division. This looks like long division with extra steps. So just turn it back into regular long division and then don't worry about it, right? So there's a lot of that you'll see in math, that people just turning questions into easier versions of themselves and then solving that. That's totally okay. All you have to make sure of is that you're not changing the question. So that's why I wrote out this fraction as 10 over 10, because that's an easy way to see that it's just equal to 1. But yeah, I hope that helps. I'm not sure if I put it in the settings for this stream for the chat to be visible after the stream is done. But maybe I'll edit the video description to say, are there going to be word problems in the test? Yes, there are 3 word problems in the test. One for fractions, one for decimals, one for percentages. Yeah, nothing too hard. The fractions one is not very hard. The percentages one is probably the hardest. Like it's probably the most little steps. I don't think there's anything that's actually like hard in the word problems, but I do think the word problems get harder as you go down the page. But that's just because percentages, like you got to do the converting to decimals and stuff. Like it's just an extra step. Fractions are like common denominator, easy stuff, right? Like while subtracting decimals, do you just do normal subtraction? Yeah, so it's just so the thing with adding and subtracting decimals is they look like regular addition and subtraction. The only thing you have to make sure of is suppose I gave you two numbers with different numbers of digits after the decimal, something like this, right? 2.42 minus 1.9. The only thing you got to make sure of for addition and for subtraction is that the decimal points are lined up. So if I write out 2.42 minus, I don't want to write 1.9. That's wrong. I don't want to put it over there. I want to put the 1 here so that I line up the decimal points top to bottom, and then I'll put the 9 there. If you've got an extra gap, that's a 0. That's what it's there for. And then you can do that subtraction problem, and then just keep the decimal lined up. So you'll have a decimal down here in your answer as well, and they're all lined up top to bottom. Let's see how it goes. Math has never been the subject where I'm the most confident. I mean, so that's true for a lot of people. A lot of people um, are not confident in their math abilities. A lot of people have not had good math teachers. I know that's not the case for you guys because your teachers are awesome. And I've seen them teach their math classes and they know their stuff. So I'm not worried about like the teaching that you've had before. But a lot of people really psych themselves out. Like a lot of people, if you've ever been in like you're playing a football match for if for anybody who's watching this later, if you don't play football, translate it to something else, another sport or game. But like a lot of the times for people with math, it's like taking a penalty in a shootout. Like you psych yourself out because of the pressure that's on you that like, oh my God, it's a math test. It's not just a test. Firstly, it's not just a class, it's a test. And then it's not just a test, it's a math test. And you just psych yourself out to the point that you make silly mistakes. You'll add instead of subtracting, you won't line up the decimals, you'll do your addition wrong. It's an addition problem. It's supposed to be 85 plus 10, and you'll do 95 plus 10 because you psych yourself out. Just like taking a penalty kick, you could go down to the park by yourself and you will hit the back of the net 10 times out of 10, no trouble. But as soon as you're in a cup final, right? As yeah, exactly. Yeah, you shoot 5 meters in there. As soon as you're in a cup final, as soon as there's people watching, as soon as there's something on the line, suddenly the goal, which is normally really, really big, suddenly looks really small and really far away, and you sky it, you shoot it way wide, right? That's what math is for a lot of people. It's not that you don't have the ability, you psych yourself out. You tell yourself you're not good at math, and then you make mistakes. The same way that you can always take the penalty kick, but if you show up for the shootout, is you're making that walk to the penalty spot and you tell yourself, I'm going to miss, I'm going to miss, I'm going to miss. You're going to miss because you told yourself that. You told yourself you were going to miss and then you did. A lot of people have that with math that they could actually do math, but somebody told them once or they had a bad test once and now they go, "Oh, I'm just not one of those people. I'm not one of those people that can do math like you or whatever," right? Like that's not true. Everybody can do math. It is it is like a language of its own. It is its own set of thought processes, but it's not impossible. It's not impossible for most people. Most people just psych themselves out. It's all a mental game. Yeah, exactly. It's all a mental game. And for anybody who's watching this later or who's watching this now but doesn't relate to the football analogy, relate it to something else. If there's another sport you play, if you're a dancer, if you're a singer, anybody can sing in the shower, but not everybody can sing in front of a crowd, right? It's the same thing. You psych yourself out. Maybe you're a great singer and you can do it in your room and you can do it in the shower and you can do it with your best friend or whatever. But as soon as it's in a concert in front of a bunch of people, you choke, right? It's all the same thing. Technically, you do math every day without thinking. Yeah, absolutely. The easy math for sure. Little simple addition, subtraction, multiplication, division, we're doing all the time, and it's like not even funny how many times we're doing it. Um, you do math when you're listening to music. Music is like the brain's way of enjoying math because music is all counting, right? It's all counting. And then if any of you have ever tried like writing music and like looking at sheet music and stuff, it's all like fractions. You've got your bar of music, and then you've got half notes and quarter notes and eighth notes, and it's just everything's divided by two or divided by three, or math is like that, music is like that, sports are like that. But the thing is, music, people will psych themselves out before a concert, before singing or before playing an instrument as part of like a band or part of a concert. Sure. Sports, you'll psych yourself out before the championship game, before the cup final, before this, before that. Math, you don't have a cup final for math, but you have an exam, right? You don't have that school that's really good at this particular game that they've beaten your school for the last 6 years, but you have tests, right? So math, that's where it comes out, is on your quizzes, on your tests, on your exams. That's your that's your championship final for math, right? That's your cup final, that's your penalty shootout. That's where you're going to psych yourself out, and then you're going to make mistakes that you wouldn't have made if the stakes were a little bit lower, if the pressure was a little bit lower. So that's why I tell you guys, find the way that works for you for solving the problems. Like, yeah, I said there's three word problems, one for fractions, one for decimals, one for percentages. If you want to turn them all into fractions because you like fractions, go for it. I'm not going to say no. As long as your final answer equals the same thing and you show your work, yeah. Because the thing with math is, I want you guys to see, and I should say this in a lesson that everybody's watching, but I want you guys to see that math is possible for everybody, that it can be fun. Obviously, not all math is going to be fun for everybody all the time. There's going to be some things you like more, you like less. I have those things too. Sure. But math is doable for everybody. Like, it's possible to be good at math. It can be useful. It can be fun. You don't have to psych yourself out. I'm sure there's mathematicians and like people way smarter than me who've like studied the brain and stuff, and they might disagree. I don't believe that there's like a mathy type of person. I don't believe that there's a type of person that's like better hardwired to do math. I think it's just people psyching themselves out. Sometimes there's little things that make it a little bit harder, but math is fun when you understand what you're doing. That's the best feel. Yeah, absolutely. Absolutely. Math is more fun when you understand what you're doing. And for me, in the last couple of years, and I mentioned this in the intro video, that I got really into chess in the last couple of years, that's part of it, because once I started playing chess properly, I'm like, "Oh, now I actually know what I'm doing." It feels like math, but it's fun because I understand what's going on now. It's the same thing what you guys are saying here, that math is fun when you understand. That's exactly it. Because nobody likes feeling confused, but if you understand what you're doing and you've done like enough of it, like you've done it enough times, you've done enough practice questions, you've done enough subtraction of decimals, then you're confident that you can do this. So you know you've learned it at some point. You know you've done questions right about it at some point. So you're confident that you can do it right again. And you have this general understanding of, I know what's going on. I know what I have to do. I know why I have to do it. And I know more or less what my answer should look like. Right? Like if you're adding mixed fractions and you see a big one and a big two, you know your answer is probably going to be three and something, maybe four and something. If you're getting an answer of 25, you know you did that wrong because you have some idea of what's going on, right? So, yeah, try not to psych yourselves out for tomorrow. I know it's a test. I know, it looks uh a little bit intimidating. How'd you learn to be good in chess? On the internet? Yeah, on the internet. Um, on YouTube, I discovered Gotham Chess a couple of years ago. He's the biggest chess channel on YouTube. I discovered him right after he became the biggest chess channel on YouTube by subscribers. He was like, I don't know, maybe 2 million maybe one point something million subscribers at the time. Yeah, I just watched a bunch of his videos and I played like 7,000 games. I'm not kidding. My chess profile on the app that I use has 7,075 games. Um, yeah, it's just that it's practice, 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 and then it's more fun when you understand what's going on, and then you get something to help, right? Like you get the I got the chess book from the guy that I was watching on YouTube. Like, yeah, incidentally, and I'm going to run this by your teachers at some point, but I was thinking of starting a chess club for you guys because it's chess has been shown to improve math skills. So being your guys' math teacher maybe would be fun. But yeah, I have two chess books. The other one is buried under some of my language books and my physics books, but yeah. Yeah. So don't stress for tomorrow. I think you're the only one left at this point maybe. It looks like there's only one viewer, but yeah, don't psych yourself out for tomorrow because you guys do better, and this is just true in general. Like I haven't seen most of you guys do a test before, but I have seen you do tests before. But yeah, it's just it's easier if you don't stress out too much about it. A little bit stress is good so that you um a little bit of stress is good so that you actually study, but beyond that, not worth it. We have a board game tournament in class and there's chess in it. Oh, awesome. Okay, excellent. Very nice. I'm glad that that's there. I would love to be part of that, but I'm a little bit too far away. Oh, my pleasure. Yeah, I'm more than happy to help out with this kind of thing, and I hope you guys don't stress out too much, but sweet. So now it looks like there's zero people here, so I will hang out for 5 minutes in case there's anybody who comes in late, anybody who has a final couple of questions. But then I will check my phone. I'll check for the YouTube comments at 8 p.m. my time, 9 p.m. your time. So yeah, and I'm always available on Instagram and WhatsApp if you guys have urgent questions. Get your parents to find me on Instagram or something. Awesome. Yeah, good luck for tomorrow. I'm obviously I haven't got a lesson or anything for tomorrow, so I will see you guys on Thursday, I guess. But yeah, good luck with studying. Take it a little bit easy after that if you can afford to. Just make sure you're ready for the test, but don't stress out after that. It's going to be great. Bye. All right. So since there is nobody left as far as I can see, but I know that number lags a little bit sometimes, but there's nobody left as I can see, and there are no more questions in the chat. So I am going to log off, but I will check in again to the YouTube comments at 9 p.m. Dominican time. So if you have any burning questions, send them before 9, and then I will check then. Beyond that, you guys should be in bed before I'm done my chess session of the evening. But yeah, good luck for tomorrow's test, and I will see you guys on Thursday, I guess. Have a good one.